we have developed a process to capture and destroy a toxic chemical that's called PFAS. PFAS is something that's been in the news quite a bit lately, but you might not be too familiar with what it is. It's an organic molecule, a synthetic organic molecule that's been around for close to 100 years. It has a number of uses that are beneficial, but it's been found to have some harmful health effects. And it is found in everything from cosmetics, textiles, cookware, to even packaging for food and beverages. This organic chemical has a fluorine carbon bond in it, and that's among one of the strongest bonds that exists. And what that means is once you make this chemical, there's really no natural way to destroy it. So as it is prevalent in all these different materials, as it's been around for almost 100 years, it's accumulated everywhere. It's found in things like rainwater in the Australian outback. It's been found in Arctic ice. So it is a problem that persists across the globe, not just in the US. But because it doesn't go away, it accumulates in your body, in animals, in the environment, in plants. And as it gets into our body, that accumulation over time causes harmful health effects, birth defects, cancers, a reduction in fertility rates, and it has been believed to be a cause of death in a number of cases. Here in the US, more than 83% of the waterways are contaminated with PFAS. That means close to 150 million people in the United States are exposed to harmful levels of this toxic chemical. It doesn't break down. And there are some people that you can do things like you can use activated carbon and some filters to pull this material out of water. But ultimately what happens is those materials have to be disposed of somewhere, often in dumps in other places, and that will result in these chemicals leaching back into the water supplies. So there's a definite need to remove these from our environment. In fact, the EPA has published regulations for the control of these chemicals that are going to get it implemented next year. So people have to do something. And what we've been able to do at Invicta Water is we've partnered with a company, BNana, who's also had offerings on NetCapital in the past. And they've developed a unique material that's made out of boron nitride that has been proven to be able to capture these chemicals, but at the same time, destroy them by breaking the bonds of the PFAS. So it is one of the only ways right now in the world to both capture and destroy this at the same time. And when you destroy it, we're destroying it into things that are completely non-toxic and naturally occurring. A little bit of CO2 and a little bit of fluorine. And both of those compounds can be very easily handled in the water stream. So we're not creating something that needs to be disposed of anywhere else. But we've taken this a bit further. We've thought about this from a engineering aspect or from a cost and implementation. So what we've done is we've come up with a process that's based completely on existing technologies that are a fraction of current uses in such a way that uses very, very little energy. You combine these materials with UV light. So essentially the energy required to power an LED light bulb is combined with these boron nitride materials to capture and destroy these chemicals. So this is something that we're really excited about. And what we have is we're well beyond the laboratory here, right? The investment in Invicta Water is going directly towards commercialization of this technology. We don't need to do any development on the experimental side. We don't need to do anything for the materials. We don't need to prove it works. We know it works. The US Navy has demonstrated that it works. There are a number of universities that have published their results using boron nitride materials going back to the 2015 and after that shows this works. So what we've done is we've taken this from the laboratory and we're ready for a pilot. We're currently in discussions with the North Carolina General Assembly to get some non-dilutive funding to install our first set of equipment at a water treatment plant in the Piedmont Triad region of North Carolina. This is going to be designed to handle 500,000 to 800,000 gallons of water per day. So this is something that we're ready to do right now. We're also in conversations with our first industry partners, and we're targeting food and beverage, things like microbreweries, water, energy drinks, hydroponics, hydroponic farming, all these different things that are introducing products that will be ingested by folks can be completely PFAS free with what we're doing. And again, what we have is we have a unique material that's combined a little bit of UV energy and completely destroys these toxic chemicals in place. And as we're preparing for these pilots, our work doesn't stop there. We are continuously improving what we do. And I saw a question pop up. When will we have filters for homes? We're working on that, but our first step is to get into the municipal water treatment centers. But To get to homes, one of the things you have to do is you've got to get your costs down, and you have to be able to destroy these things rapidly. And compared to our first generation materials, our crystals, which are probably in the 3 to 6 months time period ago, we are destroying PFAS at more than 3 times the rate from when we first started. So we are already having significant improvements in how we do that. And that translates directly into a low cost. For a municipality, we're talking less, significantly less than a fraction of a penny. On an industrial scale, when you start talking about food and beverages, again, less than half a cent per gallon is the cost that we are going to add. And this cost goes directly to destroying this material. So you could have this energy drink or this bottled water or these plants with a PFAS-free label, which we're pretty excited about. You can have PFAS-free water coming out of your municipality, so you're not discharging these toxics into the rivers or the streams, and you're not having them sent directly to your home as part of the drinking water. So what we're doing at Invicta, we're really excited about this. This is a unique opportunity, right? We have found a way to pull these toxic chemicals out of water, destroy them at exactly the same time. So we have a continuous flow, which is very cost effective, uses very low energy, takes up a very small footprint. So it should be able to be installed at any industry site or any municipality here in the United States or really across the globe. We're really excited to again be a part of NetCapital. The benefit of the crowd goes well beyond just the investments. And obviously, we invite you to invest in our company, but we also invite you to reach out to us. If you have a company that you know of that could benefit from what we're doing, or if you have an application or something that you think could use Invicta Water's technology, reach out to us. Please let us know. We would love to start that conversation, and we are looking forward to commercializing this technology really just as fast as we can.
Thank you so much for that background, Steve. It's always a pleasure having you on. Good questions coming in. Thanks for answering the first one. Another question, do municipalities report PFAS in tap water, or how do you get that data?
Some do, some don't. So as of today, there are no direct requirements to do so, but there are a lot of communities that do publish that. And there are a lot of reports that you can find out there that talk about the PFAS contamination levels around the country. Burlington, North Carolina, which is where Invicta Water is located, they actually do report it. They are having some challenges with the river that runs through the community. So they've been publishing that data for quite a while, but it is pretty readily available. The EPA has a number of good locations on their website where you can see the information. And we have links to a lot of that on our offer page as well.
It does feel like there's kind of maybe renewed, or maybe it's entirely new consciousness around PFAS and the potential dangers to the human body. Is there any insight into why you think that's happening now? My understanding is these forever chemicals have been potentially in our systems for quite a while now. Any insight to why now it's like there's a collective consciousness around it?
Yeah, I think there was and again, we have a lot of links to some of these articles and some of the things I'll talk about directly on our offer page. Also on our website, we have many, many more links to things. But there was a movie, Dark Waters, that came out a few years ago that talked about some of the challenges. I believe that was from West Virginia. Things like the Philadelphia Phillies, Tug McGraw had a rare disease that they believe that he got as a result from the turf at Veterans Stadium, which was coated by PFAS. And it turns out there's a number of Phillies that have had some significant health problems from PFAS. So there have been a lot of stories that have had a lot of publicity around some of the more tragic end of things. Unfortunately, it seems it takes bad things to get people's attention, but there have been a lot of studies on the health effects for decades, really, of these materials. But now you're finding it proliferation into the environment everywhere. There's every day, if you just Googled PFAS, you're going to see articles from, say, Michigan and Ohio, where they have warnings from the state, don't eat the fish that you catch, or don't eat the deer that you're hunting because of PFAS contamination. You're seeing things where people used to get sludge from waste treatment plants to put on their crops or to put on their fields to feed their cattle. And they're seeing that the PFAS goes from that sludge to the grass, to the cows, and they've had to destroy, some of their crops or some of their animals. So it is starting to be a challenge. And there's also a tremendous amount of litigation right now. Billions and billions of dollars is being fought over to remediate and to compensate folks that have been impacted
Can you talk a little bit about these health effects? I know, I think some of them are being researched. There's some that are like real kind of statistically correlated, but can you talk about some of the health effects from consuming PFAS?
Yeah, what they found is certainly there's birth defects. There's challenges with birth defects. There's a decreased fertility rate that has been seen for this. There is a higher distribution of some rare diseases and some rare health effects that are accumulated around areas that have a lot of contamination. And military bases is one area where they have a lot of challenges with their water. This material is in things like firefighting foams and other things that help make things waterproof in other areas. So there is a lot of this in the military communities. So you see ads even, I was in Western Pennsylvania recently, and they actually have ads on TV about if you've been impacted with any of these diseases and you think you have got it through PFAS, contact these law firms. So it's something that's, constantly being litigated right now, but everywhere from rare brain diseases to rare cancers to birth defects, you're finding problems with your endocrine systems. It's a wide variety of problems that we're just now really beginning to learn about as they're just starting to have controlled studies in some of these areas where there is a high level of PFAS contamination.
Some more great questions coming through. Can you talk a little bit about the regulatory environment for PFAS or water treatment in general?
Yeah, it's an interesting environment right now. So what the EPA has done is they have called out for regulation on, I believe it's 4 specific compounds. Now there's thousands of chemicals that are under the PFAS umbrella, but the EPA has chosen to pick sort of the 4 most prevalent and chose to regulate it specifically for the drinking water community right now, the drinking water industries. So what that means is industry can still use it. You can still use it in other places. But for those 4 chemicals, starting next year, we believe they will say that if you are a municipality, you must control PFAS below a certain level for drinking water. They've also said that they are going to implement regulations industry by industry. So wastewater might be next. Then they may go into pharmaceuticals or semiconductors or other areas, but it's going to be a challenge because these are necessary compounds. They are beneficial in a number of ways. So it's going to be almost impossible to just ban them across the board. So it has to be implemented in a way that not only allows people to do the things that are necessary, but also it doesn't make much sense if they implement regulations that make water so expensive that no one can afford to have drinking water anymore. What we've done at Invicta Water is we've really changed that cost benefit analysis. Our technology is so much more efficient and at such a lower cost that the argument of it's just going to be too expensive to implement this in our city should go away. We believe that litigation will probably drive industry and other aspects of this quicker because people are today believing they want to be more of a conscious capitalist kind of society, doing the right thing while running a business. So what we believe is the municipalities will probably act quickly after the EPA does their implementation, but we will work with industry partners that have made a conscious decision to do the right thing.
Are you ready for the pilot? And what do you imagine happens after the pilot run?
Yeah, we're ready. We've actually we've walked the facility, so we've walked the site of where we're going to do this in North Carolina, and we are really just waiting for the go ahead for the approval to get that started. And we're quite excited. It's a water treatment plant that discharges water directly into one of the rivers in North Carolina. They do about 5 million gallons of water per day. We're going to start treating somewhere in the neighborhood of 500 to 800,000 gallons of water per day just to show that it works. But this is we're ready to go. The system's designed. We're prepared. It's really just a matter of getting it started. Well, we believe if we can get this going, in the next 4 to 6 weeks, which we're very hopeful that before the end of the year, this thing will be up and running and we'll be able to have really good data. The industry partners, because they're at a much smaller scale, we could probably get that going a little bit quicker. So we're talking to people in North Carolina, we're talking to some folks in California, and some others along the East Coast to get this first application in place. It's likely going to be a microbrew or maybe a hydroponic farm. So we're quite excited about having the opportunity to give some of these customers that first chance to have that PFAS-free label on their products.
How does Invicta Water compare to other methods of removing PFAS? Excuse me.
Yeah, great question. So, one of the I say brute force methods is you just create massive amounts of volumes filled with activated carbon, and it just very slowly will trickle over these things. The chemicals will get captured in the porosity of the carbon, and over time you can remove them. But what you have though is then you have dirty charcoal that you have to dispose of. So there's a plan in Wilmington, North Carolina, that spent about 40 million in capital to dig holes to fill it with carbon, and over a 10-year period, they're probably going to spend overall about $100 million to do something that doesn't really work. We could do it for probably 10 to 15% of that total cost with almost no OpEx. Other applications like reverse osmosis or some of the unique applications like supercritical fluids require a tremendous amount of energy. They're typically at elevated temperatures and pressures. So the cost to run those is very, very high. And things like reverse osmosis and some of those, you also still have membranes and things that are contaminated that you have to dispose of. Again, what we do requires no heating, no pressure. So it's ambient room and temperature. It can be done again with just a little bit of UV energy, which is about equivalent of a UV light bulb. So it's very low cost and it destroys it in place. We do not create anything that's toxic. We don't have to do anything that has to be treated or handled further. We take care of these chemicals in place, and we take that forever chemical and we forever destroy it. So we've completely eradicated it.
I love that. Forever no more. Awesome.
Yep.
And
And
then
I
someone
see the
asked,
question about the PFAS free label. We don't have it yet because we don't have a bottled water partner yet, but we are, as we talk to folks in food and beverage, that's something that we will certainly work together to develop. And we are really excited to finally get that first industry partner started so that we can have a PFAS free bottled water.
so for folks in the crowd with water relationships or bottlers or distributors, it sounds like that's one more
Absolutely.
opportunity to coordinate with the Invicta Water team.
Microbreweries,
And,
energy drinks, all the things that are popping up around right now. We would love to be able to participate and help make their products even better. And it's the perfect time right now because we are just waiting to go, right? This funding is for commercialization of the technology. We don't have to prove the tech works. We don't have to do any other experimentation. It's get it in place. And the EPA is starting the regulation. So this is imminent. The litigation it's going crazy all around the world, how much liability the companies are going to have to get into. So industry wants a solution. People want a solution. We're ready to grow. It's the right thing to do. We're really excited that we have an opportunity to really grow the business by doing the right thing. And that's really exciting for us.